x equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
All right, so we're gonna solve a system of equations in 3 variables using inverse matrices. So in order to do that, the first thing we need to do is create 3 matrices. The first matrix is called the coefficient matrix. And it's created by using the coefficients of the variables. The variables are x, y, and z, so the coefficient here is 4. In front of the y would be what we would consider a -1, and in front of the z would be a 5. So this would be 4, -1, 5. Following suit, this would be 4, 1, -3, 5, -1, and 1. So that's the coefficient matrix. Then we have something called the variable matrix. And the variable matrix are the variables x, y, and z in order. So x comes first, y comes second, z comes third, and all the equations, they all have to be lined up and in order. And then it goes x, y, and z. Then we have something called the constant matrix. The constant matrix are the solutions over here, 0, 4, and 9. 0, 4, and the reason this should make sense is because we multiply matrices row by column. So if I wanted to multiply these matrices, this is a 3 by 3, this is a 3 by 1. So the dimensions, the columns of first match the rows of the second, so I can multiply. The dimensions of the new one would be a 3 by 1, so it would be 4, -1, and 5 would be matched with these, right, row by column. So 4 times x is 4x. -1 times y is -y. 5 times z is 5z plus 5z. And those would be paired with row 1, column 1 of this matrix equals to 0. So if I multiply this, it would be 4x minus y plus 5z equals 0, which is the same as this equation here. And so that's why this can be set up this way. You have to understand matrix multiplication in order to set this up. But this is just setting it up. Now we need to find a solution. And so we know what this matrix is, so I'm going to put it into a calculator in a minute, and I'm going to put this in the calculator as matrix A. So this is matrix A. This is a variable. We're going to call it matrix X because we used to call them variables X, and so I'm going to call this matrix X. So matrix A times matrix X would multiply and give me matrix B. So matrix A times matrix X equals matrix B. Well, I want to solve just like I would a normal equation. A normal equation. Let's say I had like 3x equals 18. Well, I would divide by 3 and I get x equals 6 and I'd be happy. The problem is I'm not allowed to divide matrices, so we have a little bit of a problem here. So instead of dividing, we can multiply this by its inverse. And we studied how to find the inverse of a matrix. So instead of using the formula that we used, we're going to use the calculator to give us the inverse of the matrix. So A inverse times A is going to be the identity matrix, which means those two are going to cancel out, and I'm left with matrix X. But if I multiply this side of the equation by A inverse, that means I need to multiply this side by A inverse. And order matters. So I multiplied A inverse on the left-hand side here, so I have to multiply A inverse on the left-hand side here as well. So this is going to be A inverse B. So matrix X is equal to A inverse B. So I'm going to put this in as matrix A, and this one is matrix B, and then in order to solve, I want to find A inverse B. So I'm going to put that up on the screen right now. So I've gone to the website desmos.com/matrix, and I'm going to put these matrices in there. A is a 3 by 3 matrix, and I'm just going to put these elements in it. And then I'm going to put in matrix B. Matrix B is 0, 4, 9. It's a 3 by 1, so new matrix, it's a 3 by 1 matrix in 0 form. And so if you recognize I have matrix A and matrix B in there, and now in order to solve I need to do A inverse B. So A, and then I'm going to go down here where it says A to the negative 1, that's going to give me inverse, and then matrix B. And then when I hit enter, it gives me the answer in negative 1, or 1, negative 6, negative 2. So I go back here. 1, negative 6, and negative 2. Just double check. 1, negative 6, negative 2, 1, negative 6, negative 2. Submit my answer, and we got it right. Fantastic. Alright. We're going to do one more. I'm going to go a little bit faster on this one because I think that we have all the basics for it. Okay, so we're going to do this problem. Well, I'm not going to write the word coefficient matrix. I'm not going to write the word variable matrix. I'm just going to set it up. So this is negative 9, negative 8, 10, negative 2, 3, negative 10, 9, 2, 10. Times x, y, z equals 0, negative 9, 2. So this is matrix A, this is matrix X, and this is matrix B, right? Matrix A times matrix X equals matrix B. And we solve it the same way. We multiply by the inverse of A on both sides. These cancel, I'm left with x equals A inverse B. So here's A, here's B, put them into my calculator, desmos.com/matrix. I'm going to clear all my matrices and start over, new matrix. Then I'm going to do A inverse B, enter, and get 4, negative 7, negative 2. 4, negative 7, negative 2. That's it. Let me know if you have any questions on this, but this is really the quick version. If you look at my lessons previously, I really spent a lot of time going through this, but this was kind of a short lesson on how to solve systems of equations with inverse matrices. This would work with the 2 by 2, 3 by 3, 4 by 4, any system of equations.